Good morning to you all. In the previous session, just we concluded how to model signals like unit step function, unit step signal, unit impulse signal, and exponential signals like that. Now we know that in the classes in the beginning, we discussed properties of signals. So one or two important properties on these signals, how could they affect or how the different type of signals will they produce. Just we are going to discuss all two or three important properties, remaining not needed. Let us start. Now, just look at under signal models, just we discussed unit step signal, unit impulse signal, exponential signal. These three signals we discussed. Now, what are the properties of signals? That is time shifting, time scaling, and time reversal. These are signals, properties of signals. These are different signal models. These are models. Now, making one or two important properties and just analyzing the impact or the output of these signals upon the signal models. Now just look at different sketches or different models you are going to get. So to get the applying one or two important properties on signal models, how they will be. For example, look at unit step signal. Unit step signal. How it could be actually? What is unit step signal for continuous time signal? So in most of the cases, we made differences between continuous time and digital time signal. So here I am mentioning you continuous. I think the remaining work for digital is very easy for you. Now just what are the unit step function, unit step signal? This is 0. It ranges here, the amplitude 1 here, the remaining for all values. This is 1. This is 1, 2, 3, 4 like this. Minus 1, minus 2, minus 3 like this. So what type of function is this? This is u of t. For example, u of t is like this. For example, what is u of minus t? What is u of minus t? Time inversion. So here you can make here just like this. Time reversal. This is t. This is u of minus t. So time reversal means what? This is time reversal. Minus t implies what? It implies reversal of the time reversal. Just look at the graph is like this. Make it the reverse, in the reverse direction. So here it will be like this, thick line. Here it is 1, here it is, look at time reversal. Look at this one, quite opposite to that one. This is time reversal property. Actually they concentrate mostly on this one. This is called time reversal property of unit step function. Time reversal property on unit step function. This is one of the important thing. Remaining things all shifting only, no problem. Second one, unit impulse signal. What is unit impulse signal? For continuous, unit impulse signal is this is t, this is delta of t. sun spike, its value is infinity, but measuring value equal to 1, 1, 2, 3 like that. -1, -2, -3. All these are zeros, thick line. Here also thick line. Now this is unit impulse signal. For this signal, what is time reversal of signal? What is time reversal of Dirac delta signal? What is time reversal? Just look at, some portion is on the left side in the previous case, some portion is on the right side in the previous case. So by making reversal, right side portion comes to left side portion comes to right side. This is okay, but here there is no right, here right side portion is 0, left side portion is also equal to 0. It stands in the mid of the graph, so there is no change. Now just look at how it will be invisible. Now just look at the same graph we are going to get for time reversal concept. Same here, same on this one. Here this is up to value infinity and measuring value equal to 1. Just look at left side 0 part, reversing it comes to left side 0 part. Here left side entire left part is 0, reversing entire it goes to right side, entire right side will be 0, but here it stands in the mid of the graph. So in the middle of the graph, whenever you reverse the graph, mid is always middle, it can't change towards this side or towards that side. Therefore this is the time reversal concepts of unit step signal and unit impulse signal as well. Now regarding exponential signal, now just look at, for example, take e power minus alpha t. That means alpha is greater than 0. Then it is t. Now the graph comes like this. This is 1. So values same. You can make it the values 1, 2, 3, etc., etc. -1, -2, -3, etc., etc. This is the graph. Now, what is time reversal of this graph? This graph equal to what? E of this graph. This equal to x of t. Now, what is the graph of x of minus t? That means what? Graph will be reversal, that is t. This becomes e of alpha t. So it makes like this. This is very much important. Just look at, that means e power alpha t is a time reversal of what? E power alpha t is a time reversal of e power minus alpha t. E power minus alpha t is equal to time reversal of e power alpha t. These two things students have to understand very clearly. That's why for everything, sketch of the signal is very much important for making analysis on each and every concept of the signals. What is the impact of properties of signals on the different signal models? So no need to have any confusion. Time shifting, time scaling, and time reversal, all these comes under the category of properties of signals. Here unit step signal, unit impulse signal, exponential signal, we call them as signal models. Again I am repeating, models are different, properties are different. Between these two, you have to make graphs in each and every instance of our discussion to get analysis between the impact of properties on the signal models. Now the next topic is, now just look at, in a signal modeling, in the previous case we discussed a rectangular model, a rectangular signal. This is a rectangular signal. Actually, what is rectangular signal? The time period can be For example, it is 2 by 2. This is minus t by 2. Now, its amplitude equal to A. Any value, t by 2 minus t by 2 like that. Now, how to model? How to model the given signal? This is x of t. X of t, generally we write it as rectangular signal. They call it as RECT, rectangular signal. RECT stands for rectangular signal. You can write x of t also. This is called rectangular. How to give a model, mathematical equation to this sketch? That is equal to rectangular signal, that is equal to amplitude A into the independent time variable, this is t, that is t by the total length, that means t by 2 minus of t by 2, it gives what? Total length, 2 times t by 2, that is equal to t. This is very much important, rectangular signal. Now just look at, if you take a signal, this is t, here the width of the signal equal to minus 1, amplitude is also minus 1. This kind of signal is called pi of t signal, very much important. This is called pi of t signal. In mathematical pi, this is pi of t. Pi of t. Now, again students have to get a clear-cut difference between these two representations. Here width is what? T by 2. Here width is what? Minus t by 2. T by 2 minus t by 2. It can be any values, minus 4 to 4, minus 5 to 5, like that only. That is rectangular value. That means the space from the origin, from this side and this side are same. It is amplitude of the signal. This is rectangular. In this case, this is special case. In this case, this is the center of the origin. This is center of the origin. That is called 0. From this side, the width equal to 1. From this also, the width equal to 1. And the amplitude is also equal to 1. In all the cases 1, 1, 1. Then that kind of signal is called pi of t signal. Especially in examinations, for short answers they will ask, sketch the graph of pi of t. That means what? In pi of t graph, the width is equal to minus 1 to 1 and the amplitude, that is equal to 1. Once these two conditions are meeting with, then that kind of graph or sketch is called pi of t sketch or graph, pi of t signal. This is called pi of t signal. So this is rectangular signal. This is also, it comes under the family of rectangular signal, but it is a different notation. It is having a different notation. What is the actually family of rectangular signal? The right side and the left side, widths both are same. Now just look at here, the width. Here, width of a rectangular signal belongs to minus t by 2 to plus t by 2. And here, amplitude. The amplitude is equal to A. Amplitude can be 1, 2, 3, 4, 5, anything. That is called general. This is generalization. This is called generalization. This is a general concept. But this is a specific. This is a specific concept. So draw the sketch of pi of t signal. That means students have to make it. Whenever they ask pi of t, students have to recollect these two important. Width belongs to only minus 1 to 1 and amplitude is also equal to 1. Under these cases, look at minus 1, 1, 1, all are 1s. In that case, the signal is called pi of t signal. This is rectangular signal, that is pi of t signal. That is a special. Therefore, note, So note, what is this note? Pi of t signal is a special case, or signal of which one? Rectangular signal, a special case of rectangular signal. They will ask in 2 marks small questions like this. So this point students have to remember properly. Thank you. In the next session we are going to start systems. Thank you.